Hello and welcome to part one of our types of sampling lesson. Again, there's going to be 3 videos in this lesson with activities in between. So Dr. Frost recommends laying out your notes like this for this part of the chapter. I have prepared a little something in advance which you should get a hold of, and it is this sheet with lots of writing on it but a few blanks which you can fill in during the lesson. So we're starting off with random sampling, of which there are 3 types. There's simple random sampling, where you just literally sample without any thought in the process. There's systematic sampling, where you're doing every, say, 7th item. And then there's stratified sampling, which used to be on the GCSE, where you divide your data up into groups and then pick random people from each of those groups to try and get a fair spread of whatever categories they're in. So what does it say here? We've got this diagram of 50 people again. Okay, but we can see that there are 4 orange ones, 9 blue ones, 15 green ones, 5 red ones. So, and how many white ones? 6 along there, 11, 17. Okay, so if I was doing a stratified sample of this, I would want to have more white, sounds racist, isn't it? More white people than green people, because they're 17 white and 15 green. I'd have more blues than the reds or the oranges if I was doing a stratified sample. However, we start off with simple random sampling. So ordinarily, we would want each thing in our sampling frame to have an equal chance of being chosen in order to avoid bias, and this is known as random sampling. And as it says, there are a few ways of doing this. So for each of the 5 types of sampling, we've got 3 random and 2 non-random. There's going to be a table like this, how to carry out advantages and disadvantages, which you can fill in the blanks on your copy. So what is simple random sampling? Well, by definition, every sample has an equal chance of being selected, or every sampling unit has an equal chance of being selected. And the methods, there's 2 standard methods. In the sampling frame, you have each item with an identifying number. So that might be on a spreadsheet, for example. And then you can use a random number generator if you want to use some technology, or you can simply put all the names in a hat and pull them out one at a time. The advantages of simple random sampling are that it is bias free because everybody gets the same chance, and it's easy and cheap to implement because you're not having to, divide your data up into groups or whatever it might be. And each number has a known equal chance of being selected. However, it's not suitable when the population size is large. If there's 70 million people in the country and you want to sample them, then you don't just want to have a possible list of 70 million people and then pick one. And of course, you do need a sampling frame. Some of the methods of sampling we'll look at do not require a sampling frame, but for simple random sampling, you do need a sampling frame. So we'll be looking at some example exam questions along the way. So this one from 2004. There are 64 girls and 56 boys in a school. Explain briefly how you could take a random sample of 15 pupils using a simple random sample. So the first thing to notice is that the fact there are 64 girls and 56 boys is irrelevant in a simple random sample. So what you could do is you could have a calculator. 64 plus 56 is relevant, so that's 120. So basically you need to allocate a number between 1 and 120 to each student. And then, as I say, you can either use a random number generator or you can use a hat, okay, with the numbers 1 to 120 in it. And then whatever numbers you pick out or generate, you look back at your list, your sampling frame, and you say, oh, okay, number 7 is this person, number 28 is this person, etc. So moving on to systematic sampling, it's still random, but what we do is we choose an item near the beginning, and then depending on how many items we want, we do a calculation to work out how far through the list we need. So what is it? Well, required elements are chosen at regular intervals in an ordered list. Okay, so we're not just choosing them completely at random, we're starting random, and then we're hoping that the list is random enough itself that if we take, say, every 10th or 20th or whatever it is, that will give us a random sample. So underneath that it says, i.e. take every kth element, I think there should probably not be an S there, where k is the population size divided by the sample size. So just to make the numbers easier, let's say you had a population size of 100 and you wanted a sample size of 20. 100 divided by 20 would be 5. So then you would start at a random position on the list between 1 and 5. Let's say it was 2. And then if k is 100 divided by 20, which is 5, then you would take every 5th person after that. So you'd have the 2nd person, the 7th person, the 12th person, the 17th person, all the way up to, in this case, the 97th person. So if you're ever asked how to conduct a systematic sample, then you really need to refer back to this formula. They'll probably give you the population size and the sample size. So you'll work out what that value of k is. And then you'll also say that you start at a random number between 1 and k, and you go up by k until you've got all your sample. The advantages of it is still simple and quick to use. It's maybe not as simple as simple random sampling, but it is very quick. And it is also suitable for large samples. So if you had a list of 10,000 people and you were looking at every 100th one, it will be very quick just to you find your first one, and then it's very easy to find the rest. Disadvantages, well, again, you still need a sampling frame because you have to have a list. And as I said before, if your sampling frame is not completely random, then you might end up picking on a certain feature depending on how the sampling list is, the sampling frame is laid out. So it could introduce bias in theory. Okay, we have another exam question, this one from 2009. A telephone directory contains 50,000 names. A researcher wishes to select a systematic sample of 100 names from the directory. Explain in detail how the researcher should obtain such a sample. Now, it's only 2 marks, but I can tell you what they would like you to say. They would like you to divide the population by the sample size, so 50,000 divided by 100. That's going to give you 500. Okay. And then you need to choose the starting position between 1 and 500, which you can do using a random number generator. So let's say you're starting at 286, and then you would do the 500th element after that. So 286, 786, 1286, etc., until you had all 100 names in your sample. Okay, obviously you need a sampling frame to do that. Okay, and you need to use some sort of random number generator /hat in order to work out the first person in your list. Okay, and then from then on, you're just going up by 100 every time. Let's see what the answer says. So it says randomly select a number between 0, 0 and 499. That's assuming that you call the first person 0. I would have called it 1, which is in brackets. So 0, 0, 1 and 500. And once you've done that, you then select every 500th person. So notice they have used the population and sample size to get the 500. And then they've also said once you've done that randomly, then you need to move on every 500 people. So for stratified sampling, as I said earlier, it's basically based on proportions of the group. So if you look at our diagram of faces, we can see that there are 20 blue, 15 green, 10 orange, and 5 red. So if we wanted to sample, say, for example, 10 of the 50, then we would want 20 50ths, i.e. 2/5, to be blue. That would be 4 out of the 10. We would want 15 50ths, which is 3/10, to be green. That's 3 out of the 10. We would want 10 50ths, or a 5th, to be orange. That would be the 2 out of the 10. And we would want 5 out of 50, which is a 10th, i.e. 1 of the 50, sorry, 1 of the 10 to be red. So what's it say left? We want to sample 20% of the population. If the population were divided into distinct groups, e.g. age ranges known as strata, we could randomly sample 20% from each group, ensuring each group is equally represented. Indeed. So how do you carry it out? Well, you divide your population into groups, which are called strata, as it said, and then use a simple random sample within each group. You're doing the same proportion of sample size divided by population size from each strata. So again, coming up to here, let's say that we wanted to sample 10 people out of 50, then the sample size would be 10, the population size would be 50. 10 divided by 50 is a 5th, so you want a 5th of the blue people, a 5th of the orange people, as I said before. And you use that when a sample is large and the population is naturally divided into groups. Of course, it will often depend what you're actually trying to find out. Okay, so if you're trying to find out, say, voting intentions, for example, then you might want to divide people. If everyone was a Labour voter or a Reform voter, then you're not going to get sensible data out of it. Advantages: it reflects the population structure and it guarantees proportional representation of groups within the population. But the disadvantages: the population must be clearly classified into distinct strata, and selection within each stratum is going to suffer from the same disadvantages as we had for simple random sampling. Okay. Okay, so we now have an exam question on stratified sampling from 2006. A school has 15 classes and a sixth form. In each class there are 30 students, and in the sixth form there are 150 students. There are equal numbers of boys and girls in each class and equal numbers of boys and girls in the sixth form. The head teacher wishes to obtain the opinions of the students about school uniforms. Explain how the head teacher would take a stratified sample of size 40. So the first thing we need to do is to work out how many people there are in total. So if you've got 15 classes of 30 students each, that's 450, plus the sixth formers makes 600 students. Now the head teacher wants to take a sample size of 40. So according to the formula, I mean, you can do it either way up, it's up to you. But if you divide the sample size by the population, 40 divided by 600 is 2/30. That's a 15th. Okay, so we're at 1/15. Now looking at the possibilities, I would assume, I mean, it's a 7-mark question, so I'm assuming that we're not just dividing them into the classes in the sixth form, we also divide them into boys and girls. So, as I say, we want 1/15 of whatever group we've got. So let's say we're doing the sixth form. There's 150 students. 1/15 of that is 10. But if we want to do it as boys and girls in different strata, then we would, because there's equal numbers, we divide that by 2 again, and we would have 5 boys and 5 girls from the sixth form. For the 15 classes, that's 450 students, of which 1/15 would be 30. So in this case, divide that by 2 to get in boys and girls, we would want 15 boys and 15 girls. But that's not the end of it, because then you need to know how to sample it. And once you've done your calculating of how many people are in each stratum, you then need to use a random number. You need to use simple random sampling, so maybe a random number generator, or put the names in a hat, or whatever it might be. Okay, and they will expect you to write that sampling method at the end to ensure you get the 7 marks. Let's see what the answer says. So they've worked out the total in the school is 600. They've worked out that they've divided 30 by 600 and times by 40, so that's 2 from each of the 15 classes. Oh, I see. So they haven't just divided it into the classes as it is, they've divided it into each class individually. So that is a little mistake of mine, because I basically had, I just had 30 in total from the 15 classes, which was 15 boys and 15 girls, but they're saying they want 2 from each of the classes, and presumably on that basis, as we can see later, they want 1 girl and 1 boy from each class. So they've gone into a bit more depth than that did. In terms of the sixth form, we're just dividing 150 by 600, which is a quarter, times that by 40, so we want 10 students from the sixth form. So then we want to divide the sixth form, the 10 sixth formers, into 5 boys and 5 girls, and randomly sample that. And as they've gone for each of the 15 classes, having 1 boy and 1 girl, as it says there, they're labelling the boys in each class from 1 to 15 and the girls from 1 to 15, and then using random number generator or hat to select 1 of each. And then in the sixth form, again, there's 75 boys and 75 girls in total. Okay, so we would use that frame to sample 5 boys and 5 girls. Okay, thank you. That is the end of our lesson. See you later.